Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
In problem 69, a microwave oven produces electromagnetic radiation at wavelength 12.2 cm and produces a power of 720 watt. Calculate the number of microwave photons produced by the microwave oven each second. So this question is from chapter 27, Early Quantum Theory and Models of the Atom. So the wavelength of the electromagnetic radiation given as 12.2 centimeter. So we can convert into meter. So we can write 12.2 into 10 raised to power minus 2 meter. Now apply the concept of power here. So the power of radiation, power of electromagnetic radiation, that is 760 watt. So this value is given in the question, and the energy of photon, as it is related to frequency, that is E is equal to h nu, and this E represents the energy, h Planck's constant, and nu is the frequency. All right, and also the relationship between the frequency and wavelength, nu is equal to c by lambda. So we can write energy is equal to h nu, and nu is equal to c by lambda. So energy is equal to hc by lambda. So here c is the velocity of light, velocity of light, whose value is 3 into 10 raised to power 8 meter per second, and this lambda represents the wavelength of photon. Okay, so we can calculate the energy here, and h is the Planck's constant, whose value is 6.63 into 10 raised to power minus 34 joule second. So energy is equal to 6.63 into 10 raised to power minus 34 joule second, multiply by 3 into 10 raised to power 8 meter per second, and the wavelength is 12.2 into 10 raised to power minus 2 meter. So on solving this calculation, we get the energy, which is energy of photon, which is 1.63 into 10 raised to power minus 24 joule. So this is the energy, but what we need to calculate, we need to calculate the rate at which the photon are produced in the oven. So the rate at which photons are produced in the oven. So we need to calculate the number of microwave photons. So in order to calculate the photons, we can simply write energy is equal to, we can write the relationship between the power and energy. So power is equal to N into E. So here P represents the power, E represents the energy, and n represents the number of photons. So we can write n is equal to power by energy. So the value of power given in the question, that is 760 watt, divided by energy that we already calculated, 1.63 into 10 raised to power minus 24 joule. So on solving this calculation, we get the value of n, which is 4.66 into 10 raised to power 26 photons, or approximately this value is 4.4 into 10 raised to power 26 photon per second.